Hello, welcome to video 2.3a, the product and quotient rules of differentiation. So, unfortunately, the derivative of the product of two functions is not equal to the product of their derivatives, although it would be very nice if it was, but it isn't. So, here's the product rule, and you're going to have to notice that there is in a product, because very often, as you know, between, for example, a constant and parentheses, we don't put a symbol, so you have to know that it's there. So here is the product rule. The proof is in the book, and of course uses the limit definition. And basically what it is, it's the first factor times the derivative of the second factor plus the second factor, considering these two are factors of the product, times the derivative of the first factor. Now, because it's a sum, the order doesn't matter. However you want to write it down, whatever works for you. You can write it without the x's and just write f times g. A lot of people like to use u and v, although u and v start to look alike after a while, so I'd be careful about that. Okay, so here's an example. Now, actually, we have a choice here. We already know how to do this by hand, which we've already done in section 2.2, which is to actually multiply it through. So in this case, it actually is faster. Simply distribute, get the polynomial, and then find the derivative. On the other hand, you could use the product rule. So that would be, if you call this u and v, it's the first factor times the derivative of the second factor plus the second factor times the derivative of the first factor. You then distribute, you add the like terms, you'll notice we get the exact same answer. Here's one where they say find f prime of x and f prime of c. So c is the number, the constant 1. So in this case, again, you could actually by hand, if you wanted to, expand the whole thing. But let's use the product rule. So the product rule means you're going to take the first factor times the derivative of the second factor plus the second factor times the derivative of the first factor, and then you could expand. Now, if I believe the back of the book, the answers are all expanded. For example, the answer would be this right here. So what you can do if you want is just get to this point right here and then just do menu, 3 for algebra, and 3 expand. So you have expand, and then in the big parentheses you'd have this expression, and the calculator will give you this. Now, you'll notice underneath here I factored, and over here I factored out the 2 from the x minus 1. I also factored the difference of 2 cubes. And the reason for that will be later on we're going to want the derivative in its fully factored form. So I have an x minus 1 here, and I have an x minus 1 there. Actually, I have an x minus 1 squared here, and I have 2 x minus 1s here, which is another x minus 1 squared. So I factor out the x minus 1 squared, leaving me with 3x squared. I have the plus 2, and I have the x squared plus 1. Simplify the interior of this, and you now have it in fully factored form. Then, of course, they ask you to find f prime of 1. It doesn't matter in which one of these you do it. Substitute x equals 1 into any one of these expressions, and you'll get 0. Now, for the quotient rule, again, unfortunately, the derivative of the quotient of two functions is not equal to the quotient of the derivatives of the two functions. Obviously, this is a more complicated formula, so the derivative of the quotient of two functions in the denominator is the square of the original denominator, and in the numerator you have the denominator times the derivative of the numerator minus, and that's important, that means that these are not interchangeable as far as order goes, minus the numerator times the derivative of the denominator. Again, many different ways to write this out. Here it is without the x's. Here it is with u and v. I know some people use the low d high and high d low. That one's never worked for me very well. Personally, my favorite is to learn it as it's denominator times derivative of numerator minus numerator times derivative of denominator all over the denominator squared. So here's an example. So we have the denominator squared. We have the denominator times the derivative of the numerator minus the original numerator times the derivative of the denominator. Now, you won't leave it like this. The book will actually expand, and you would have to start with that anyways. You cannot cancel. Be careful. You might think, oh, I can cancel this x squared minus 1 with one of these. You can't because of the minus being there. So you're going to simplify the numerator. So you're going to expand all this. And then at the end, you would see if you could factor this numerator. In this particular case, you cannot. You'll notice the only thing I did do is I did factor the x squared minus 1. And then each one is squared. Here's another example. So again, denominator squared, denominator times the derivative of the numerator minus the numerator times the derivative of the denominator. And again, after that, it's just simplified. Okay? And eventually, you'll always want a single simplified factored fraction. And that's the end of video 2.3a.